Hello everyone, happy to be with you all today. I hope you enjoyed the keynote as much as I did. Quite a lot of great information on recent and upcoming capabilities. So since this presentation includes some forward-looking information, a quick detour to the traditional legal slide. Unknown unknowns can happen and plans can change. You know the story. Since IT has moved from supporting the business to being the business as digital is taking over the world, companies are now leveraging new cloud technologies to meet the needs of the business. Containers, orchestration, service mesh, serverless, and so on. All of that mixed with legacy technologies that cannot be abandoned. And while these technology allow teams to release faster than ever before, they also add to the complexity of application environments and the challenge of gaining visibility into them. So when you face challenge problems, it's more difficult than ever to pinpoint the cause across the distributed services and systems, as Kafka message queues, databases, orchestration, problem downstream in a different application, or a problem with a third party altogether. And without an end-to-end higher level view, we're left in the dark. In fact, many of you tell me you feel like you're flying blind today. So your first reaction may be to throw more monitoring tools at the problem. Yeah, it's true. Cloud providers have built-in monitoring solutions as AWS CloudWatch. We integrate with it, by the way. AWS X-Ray, Microsoft Azure App Insights, Google Stack Driver, and the list goes on and on. But ultimately, I do believe you're building new silos. And remember that APM was about breaking silos. And by using them, I believe you're putting new ones in place, since each of these great solutions only know about their own technology domain. Okay, you can't use AWS CloudWatch to know what's happening in your traditional data center, or to know what's happening on Azure. And many of your application spans those different technical areas. So what about end-to-end? From your front end, on-prem, multi-cloud, from your mobile app websites all the way down to your databases and supporting infrastructure? Do you have visibility into your customers? Which ones were affected? What were they doing? Do you have any idea of the business impact? So I believe you need to keep a higher level view combining business impact, customer experience, and technology health wherever that technology is. So for the whole stack, on-prem, in multiple clouds. And that's what AppDynamics can help you with. We know how your applications behave, why they behave this way. We know how they serve your users, who they are. What's the business impact? How much business think e-commerce shopping cart is at risk? So you can prioritize better. For instance, with traditional monitoring problems, you might come in the morning seeing you had 10 issues during the night. And then you would say, oh, this one happens twice a day, let me tackle it. With AppDynamics, when you come in the morning, you will see that you had 10 problems, 2 impacted customers, and 1 impacted the revenue. Which one should you tackle first? And we're not the only one to believe that you need an holistic monitoring spanning more than one technology stack, think AWS CloudWatch. According to Gartner, if you don't have such an holistic monitoring, and few of you guys plan to have one in place, around less than 15% in fact, they say you put your old cloud investment at risk. Just given that most of your application don't rely on a single technology stack. They always connect back to an on-prem service or to a legacy system, most of the time at least. So let's come back to AppDynamics and a quick overview for the ones not knowing us well yet. So basically with AppDynamics, you deploy agents where your application executes. And they do an auto discovery of your application landscape. So they see all the elements, how they are connected, how they interact, how they behave. And within minutes, you have a live architecture and where all those parts execute. Let's say some parts in Google Cloud, other parts in Azure, other parts in AWS, bunch of it on your traditional data center in the US, another part in Europe, etc., etc. The second key ingredient to understand is what we call the business transaction. So it's really our DNA. In essence, it's another name that exists for a long while from transaction tracing. So whenever a transaction starts, we give it a unique ID and we track it all the way through whatever the location, whatever the technology stacks is being pulled into executing that transaction. And that helps make complex easy, because as your application architecture changes, the BTs don't change most of the time. Think of a BT as getting a quote, as booking a ticket, etc., etc. And on those BTs, business transactions, we can collect any metrics you'd like, from execution time, like end-to-end execution times, and all the details by chunks, to user identifiers, to shopping cart current value, to you name it. Basically, since the agents are within the application, so you deploy them at production time, no need to change the code, right? But since they're spying your application, they can report back any metric you'd like, whether technical ones, business ones, etc., etc. So now let's focus on the topic of the day, how we help you with microservices. So we will first have a look at serverless, more precisely AWS Lambda and Azure Functions. More and more of you are using it, but for the ones not entirely familiar with the topic, a quick summary, my quick summary at least, would be it's an event-driven serverless computing platform. It's a developer's dream. They can write their code and the rest is taken care of. No need to monitor, scale, etc., etc. It also has some built-in observability, but once again, I do believe it's a silo. For instance, what about the upstream? Who called me? What about the downstreams? What happens when I'm done? Who are the customer? So on and so forth. On our end, it's just another agent doing the same job, reporting the same kind of rich data. You pick and choose what makes sense to you. And it puts that data in the context of the rest of your application wherever it executes. So automated discovery, end-to-end transaction tracing, traversing the serverless environments. Once again, working both for AWS Lambda and Azure Functions. The second element I'd like to spend more time on is Kubernetes. So the main focus of the day, Kubernetes. It's getting huge momentum lately. For good reasons. It's a technology that truly helps people scale their digital business, innovate faster, fear less failures, deploy application with more confidence. It enables higher deployment density, can put more application per host. It facilitates workload portability across environments. It makes your multivariate testing easier. It has kind of built-in horizontal scaling. Makes multi-tenancy in SaaS way easier. And some surveys support that adoption. For instance, 2019 Container Adoption Survey listed that 87% of respondents do run container. We're up from 55% in 2017, of which 90% run them in production. So kind of containers is a given. On top of that, 40% of enterprise companies, so being 5,000 or more employees, run Kubernetes in production. According to another survey from 451 Research, 71 cited visibility as the top concern, only second to security and compliance at 75%. So people, by large, use containers in production. 40% use Kubernetes to orchestrate those containers. And the number 2 problem behind security and compliance is visibility. So we released a new Kubernetes cluster agent, which supports all distributions on-prem, in the cloud. So think DIY, deploy yourself, EKS, EKS Fargate, AKS, GKE, OpenShift, Rancher, Docker Enterprise, CCP, etc., etc. And it's certified on OpenShift, and more to come. So things of interest. It's a first-class citizen, so you have a single instance per cluster with minimal permissions, no need for elevated privilege. So it's usable in most restricted environments. No need to change a single line of code. You don't need full host access. It's fine if you just have access to one or more namespace and not the full host. And it helps you on many aspects. So basically we monitor 2 things. We monitor the Kubernetes cluster itself, its internal state, its health, for you to better understand its behavior, so that it's no longer a black box, a fully automated black box. And so first, the Kubernetes cluster itself, and second, all your pods, your application running in that Kubernetes cluster. So on the visibility side, it's not only about pulling in KPIs like cluster events, pods, deployments, daemon sets, jobs, replica sets, resource quotas, think CPU memory storage, resource consumptions relative to these quotas, connectivity to pods via services on services endpoints, visibility to the Kubernetes host, machines running your Kubernetes clusters. So it's not, well, as I said, it's not only about collecting all these, it's about baselining them so that you can have anomaly detection and alerting both on the Kubernetes clusters and the applications running into them. These analytics, collected analytics, are fully linked with the rest of data points we collect with the other agents. So that enables bi-directional exploration between the application metrics and the Kubernetes one. It helps you not only in visibility, but also on mean time to detect and mean time to identify, MTTD and MTTI. As you can see on the screen, I'll go quickly more on that in the demo to follow. All these analytics are grouped into categories in order to help you quickly understand where the issue is coming from. So for instance, where's my mouse here? As you can see here, does the problem come from my application running inside Kubernetes? I can have an idea thanks to the pod restarts and crash loops, likely an application problem. Does the problem come from misconfigurations, insufficient permissions, or quota violations? I can see that in the image configuration data, storage data, or is that a resource problem? I've set the right quotas, etc., and you're going to have all the insight. So in a nutshell, with AppDynamics, you can have full stack visibility. Adopting new technologies doesn't mean you need to have new silos. You can keep a unified end-to-end view, from your application code to any supporting infrastructure and services, whether on-prem or in the cloud, whether legacy or leading edge. The next key capability I'd like to discuss with you in that microservices context, given their sheer complexity, short-lived distribution, etc., new failure modes, in short, is Cognition Engine, which can be of huge help. So we discussed in the keynote what we released recently, what we plan on delivering in the future. Think of it as a collection of AI/ML engines, each focused on a given task. The first one is Dynamic Baseline. We have that for a long time. We kept on improving it. So basically it learns what normal looks like and identifies seasonality. Once a baseline is established, it can detect anomalies. Without any setting complex rules or thresholds or whatever, this engine would tell you, something wrong, something not behaving as it should. Once a problem has been identified, it can trigger alerting, and we can discuss that in the demo. And the third phase is the AI/ML engine can look at all the data from infrastructure to running pods to response times of called services elsewhere in your data center and a third party to identify and group probable root causes. So it's going to come up with a conclusion. I believe you have this problem because of that, and this is why I believe so. Once again, more in the demo. So basically the iEngine is not yet another black box. It helps you, it guides you, it filters all the data, thousands, millions of data points, and shows you the ones he believes can explain what's happening and why he believes so. So you have all evidence at once on the screen to make up your mind and at least guide you in your research. So now time for the demo. So here we see the default dashboard used by the AD Financial team, fictitious company, and they're using it to bring all of their technical, business and customer experience information together to quickly gauge the overall situation, whether their technical systems are performing correctly, whether they're delivering great on a business standpoint, and whether the customers are happy. So today, this is something we know many companies struggle with, still having many monitoring tools working in silos, one for given technology stacks, others for other technology stacks, yet others, etc., etc. So with AppDynamics, you get all of this information together in real time for immediate understanding and action. So across the top, we see the key KPIs. So our current active customers, we can see here, how it evolves over time, more business information like the dollar amount which was deposited through the systems, as well as an overview of the technical information like response time and error rates. And since that application is hosted on AWS, we can track in real time the spending on Amazon. We can see here a quick view of key business transactions. So logins, deposit, transfer. So the key processes people go through in the current application and how they behave from a business standpoint and from a technical performance standpoint. We can track how they relate to one another and how it evolved. As you can see, we got a real-time update. So from logging to search to select. So here we can see the abandonment, which is really big in the confirm reward, and we can see there's some red, so we have some technical errors. That's how I explained that. And the last bit we won't go in detail today is about the reward business journey. So how we can stitch together multiple applications to track the business process end-to-end across many applications, data centers, etc., etc. So since we saw some technical issues in the previous dashboards, let's investigate further. So we can see, if you remember well, it was in the reward services, and we can see it appears in red now. So we're going to have a quick overview of our cognition engine and how it can help us. So I'm going to go to events first, and I can see that some anomalies were detected. So on top here, we can see the timeline. And if I move forward, I can see when it's moved from a warning to a critical state. So this flow map, this structure is a subset of what we had before. And the cognition engine, based on its anomaly detection engine, the baseline engine, triaged all the data and is now surfacing only the ones making sense to help us understand what happens. So what we can see here, the top suspect cause is reward services, and here we can see all the metrics, and that led him to believe this was the root cause, the origination of the problem. I won't go into detail on that, but you can see some automated actions were made, such as sending an email, ending an HTTP action, or starting a remediation script. So now that we've done full domain isolation with the cognition engine, let's dig further. So now I'm going to spend the bulk of the time on the Kubernetes cluster agent. So if you want to see a more in-depth look at our cognition engine, I recommend you attend the other session we have on the topic. So now let's have a look at how the AppDynamics Kubernetes cluster agent can help us. So I'm going into my servers, having a look at my cluster, selecting one of them. So to start with, we do monitor two different things with the cluster agent. We monitor Kubernetes itself, and then any apps running in Kubernetes as pods. At the first glance, this is the dashboard you're going to see, where you have a lot of metric in a single pane of glass. So we can see the errors. Do you have any errors, evictions, and threats? So things about to go wrong. Then we can see the pods by phase, the capacity, some issues by categories. So the different categories, we can see the application and application code issues here, where you can see we don't have any errors, but if there were any pod restarts and crash loops, you can likely think, okay, my application has a problem. Now, if your problems are more in line with misconfiguration, permission quotas, you would see them there in the pod issues and image issues or storage issues. And you can have a third category of problems, which is resource consumption, and you would see them there. So anything about the current usage, we once again saw a real-time update, or quota not being respected. So let's go to the next view, the inventory view. So here it's an overview of the Kubernetes internals. It gives us a visibility into any potential violation of best practices, such as do we have any privileged pods, do we have any namespace without quota, do we have any pods without proper health rules and alerting, do we have any missing dependencies, think no config map, no secrets, or were they removed after deployment. Do we have any missing routing processes to the application pods? Do we have some unused services? Or do we have service endpoints with IP not being in ready state? So let's go to the third view, the pods view. Here we see all the pods in my clusters at once. And here I can search by name, namespace, or any other metadata. So we're going to have a closer look. I'm going to have a criteria. I'm going to search by name. And then in the name, I'm going to search reward. And here I can see my reward entity, which seems to create some problems. And if we have a look, we can indeed see that the CPU spikes up. But we also get some other views. So let me remove that. We can see the number of restarts, so that's a demo effect. I don't have any, but I could see the other kind of problems. So let me come back to the dashboard view for a quick summary. So AppDynamics Cluster Agent is not only about monitoring your running application, but also the Kubernetes cluster internals. It's about ingesting analytics. It's about baselining them and being able to be alerted on both how your application behaves. Do you have any pod restarts, crash loops, does response time go up and down? But also the Kubernetes internals, where you can know about misconfigurations, insufficient permissions, quota violations, whether for images or storage, as well as resource consumptions. Our cluster agent not only works for Docker as containers, we see more and more lightweight alternatives as the CNCF containerd be used, and we provide equal visibility to container performance no matter what the underlying container runtime is. This cluster agent insights can also help with capacity planning. So as you remember, I told you we baseline every metric we collect. So these baseline serves as guidelines for setting proper resource requests for the normal traffic patterns and resource limits to accommodate peaks. We also track missing dependencies. For instance, most applications rely on config maps and secrets, and when missing, they will prevent proper deployment or lead to failure if they are removed after deployment. And AppDynamics tracks that and warns you when that happens, and you can find the root cause, which is outside of your application code, but really your Kubernetes cluster configuration. And the last area we can help with is all anything related with connectivity. So we proactively identify all application pods that expect connectivity, and we'll alert you if a matching service is not available. That's it for the demo. Let's come back to the slides. So would like to mention a customer, Alaska Airlines, who went microservices with AppDynamics in an Azure cloud environment. So the key takeaway to them was they had a mean time to detect that went from hours to less than 10 minutes. They have 60% less severity 1 outages, and they had a faster MTTR mean time to resolution thanks to Cognition Engine, and you can hear from them in the session later today in the round table. So I extracted a short clip of the video you can see on our website. Let's hear what they have to say.
Cognition Engine is taking that dynamic baselining to the next level. The ability to quickly figure out the root cause is a big deal for us, and we are using Cognition Engine to make our mean time to resolution even faster. Our mean time to detection went from hours to less than 10 minutes, which is a huge win for us.
From 2017 to 2018, we were able to reduce the number of Sub 1 outages that we had by 60%, and we're continuing to sustain that.
We are using a hybrid environment on-premise and in the cloud, a lot of microservices and serverless computing.
So a few takeaways from you from that session. First, with AppDynamics, you can keep an end-to-end visibility from the front end to the back end, from the technology health to the business health to the delivered custom experiences. You also have a full stack understanding from your application themselves to all supporting infrastructures, whether traditional or cloud-based. And finally, you can have unified insights in metrics, traces, logs, down to the line of code. All of that helped with AI-driven insights, as we've seen with Cognition Engine. As next steps, I recommend you have a look at a session which goes deeper into the Cognition Engine with Jeff Heward. And the session is named Achieve Rapid Diagnostics with the new AI-powered root cause analysis. You can also come on our website, appdynamics.com/transform-now, to discover more about the products, request demos, and sign up for better programs. It's been a pleasure, and thank you all. Bye.